the cells to survive in fluid medium called the body's internal environment, and that is homeostasis. So it plays a significant role in homeostasis. Number B, it helps in the growth and function of the cell. Number B, it helps in the growth and functions of the cells. How does this happen? All end products of nutrient metabolism, such as glucose, amino acids, free fatty acids, and vitamins and oxygen, are transported in the fluid to supply the cell. So it helps in the growth and functions of the cell. Number C, in transport mechanism. Of course, the body water or body fluid forms the transport mechanism by which end products of nutrient metabolism and other essential material reach the cell. Number question? I thought they had it up. Okay, number D. In metabolic reactions, it is also significant in metabolic reactions. In fact, the water inside the cell forms a favorable medium for metabolic reactions. And these metabolic reactions are very important for growth and functional activities of the cell. Number what? Number E. Is it number E or number D? D. Okay. It also helps to regulate body temperature. So body water or body fluids, they play a significant role in thermoregulation. So then it helps to regulate or maintain normal body temperature. Is anyone lost? Okay. Going forward, we'll now look at regulation of body fluid or body water. Regulation of body fluid or body water. Body fluid can be regulated by three key structures in the human body. Number one is the hypothalamus. All right, the hypothalamus. Do you all have hypothalamus? Are you sure? Okay. The hypothalamus is one structure in the human brain that helps to regulate body fluid. In fact, it is part of the nervous system. So the nervous system in concert with the endocrine system helps us to regulate body water or body fluid. So the hypothalamus, this test center, is what we call the test center. It is located in the brain. So when the test centers are stimulated, what happens? What happens? You begin to feel like taking water, right? Okay. Stimulation of the test center occurs when your body is lacking water or when one begins to get dehydrated. You don't just get up to drink water. There are things that stimulate the test center for you to rise and take water. So one way in which water gets into the body is stimulation of test center causing you to drink water. And then this will help to normalize the water deficit in the body. Kosi. Is Kosi here? Is the person in medicine? Med-Surg 200 level?
Yeah.
Anyone Kosi? Do we have any Kosi who? Agu. Agu Kosi, please. You have a visitor, come out.
Are you her mother?
Yeah, I'm the aunt.
The aunt?
Yes.
Just stand as I show. Or you want to drop this one?
Yes, I want to give her.
Okay.
Sorry.
Thank you, ma'am.
Connect.
All right, thank you. No noise, no noise. No noise. Agu Kosi. Your lab coat is on my table, so after the class, come and pick it. So drinking of water due to stimulation of the test center will normalize the water deficit, bringing it to normal in cases of dehydration. Okay? Number B, another important structure in the body that helps to regulate body fluid is the kidney. Yes, it's the kidney. So the kidney is also, it also serves as an endocrine gland. Alright? Because it secretes certain hormones that helps to regulate not just blood volume but also the ECM volume. But in this aspect, whenever a person is dehydrated, the kidney will help to conserve water. You're going to do that in renal physiology. So if your body water content is low, the kidney senses it and it conserves water. So the urine you pass at that moment or period, the volume is going to be small and the solute in the urine is going to be more. So you have a concentrated urine. Alright? So whenever you go to the convenience to urinate and you observe that the volume of your urine is very small, it means that your body water content is either low and the kidney would help you to conserve water by reducing the volume of water that is excreted to the exterior. So it plays a significant role in the regulatory mechanism of water content of body fluid. Very important. Conversely, if your body water content is high or more, in cases of edema, the kidney is going to, cause excretion of large volume of water in urine. Now, rather than conserving water, it excretes water. So, and when you go to the convenience or pass out urine and you observe that your urine volume is high or more or large, it simply means that maybe you have taken a lot of water than required, or your body has more fluid which needs to be excreted. So when you go to the convenience, you pass out large volume of urine. And in that large volume of urine, you have more water content and less solids. So that urine is known as the diluted urine. So the kidney is one key organ that helps us to regulate body fluid. And then the next thing are hormones secreted by some endocrine glands. Under hormones, you have the renin, angiotensin, and aldosterone system. The renin, angiotensin, aldosterone system. This system helps you to regulate body water when it is in excess or when it is less. In fact, renin is secreted by the kidney. Alright? And a lot of reaction occurs. First of all, it will lead to the conversion of angiotensin and then from there, the whole of that mechanism will lead to secretion of aldosterone by the adrenal gland. We are going to do this in details in renal physiology and endocrine physiology, the renin, angiotensin, aldosterone mechanism. I don't want to dive into details of that, so I don't confuse you. But this hormone is important in maintaining body water of every human being. And then there's another hormone that plays a significant role in the regulatory mechanism of body fluid, and that is the antidiuretic hormone. The antidiuretic hormone, also known as vasopressin. This hormone is secreted by the posterior pituitary gland. You are going to do all of that under endocrinology. The posterior pituitary gland secretes antidiuretic hormone, also known as vasopressin. 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 So when you hear of ADH, you short form of anti-diuretic hormone is ADH. Another word for ADH is vasopressin. And that hormone is secreted by what? The posterior pituitary gland or the neurohypophysis. You will do all of that under endocrinology. Alright? So basically, what nonsense am I talking about? There are nervous and endocrine mechanisms that helps us to regulate body fluid content or body water in every human being. As you proceed in your career, you will get to know all of that. Any question? Questions, reactions, and query? Okay. Water balance. You're going to do that under renal physiology. So let's go forward. You have a question? Okay, let me just summarize that. Water balance. Alright? The body fluid water is supposed to be balanced in every human being. If your water content is lower, well, you may suffer from dehydration. As simple as that sounds, it is a serious clinical. And if you have dehydration, you might require to be admitted and given infusion. The same thing with edema. If you have edema, it means you have excess water in your body. And that can cause all of your cells to swell, and it will even cause you to begin to swell, and you may even burst if that condition is not arrested. So edema and dehydration are two serious clinical conditions, even though they sound very simple. Alright? Now, water balance simply means or refers to the maintenance of body water content under normal physiological limits or condition. Okay? How does water get into the body? They are all highlighted on this slide. How does water get into the body? Number one is by drinking water. Water can also enter your body through the food you eat. Alright? Another metabolic origins. So about 2,500 ml of water can get into your body daily. And the water output simply means how water leaves the body. The first thing here is through the urine. In fact, the majority of the water in the body goes out of the body through the urine. And about 1,500 ml of water can be passed out of your body on a daily basis. Another way through which water leaves the body is through sweat. Through sweat. 500 ml of water leaves the body through sweating. Okay? And then through feces. About 100 mils of water can leave your body through physics. And then via expired air, as you expire, water is also leaving in form of vapor. So about 400 mils of water can leave your body through sweating. So the question would be, what exactly is water balance? What exactly is water balance? Water balance refers, okay, the cause when water intake is equal water output. So when intake is equal to output, the body is in a state of water balance. Alright? Intake must be equal to output. The water is balanced. There are two main kinds of water balance. We have positive and negative water balance. Positive and negative water balance. A positive water balance. What does it mean? It means that intake has exceeded output. Positive water balance. Intake is higher than output. That is positive water balance. And that can lead to conditions such as edema. Alright? When water intake is more than water output, the clinical condition known as edema can occur. And you can see the signs and symptoms of edema. Alright? The picture on the slide. The leg of the patient swells. That means they are filled with fluid, edema. And then you know that the water content of that person is not balanced. Edema. Edema can occur in clinical conditions such as heart failure, renal failure, malnutrition, and inflammation of tissues. Alright? So one of the commonest signs to note when someone is having heart failure or renal failure is swelling of the feet. This is one of the commonest signs to know when someone is having renal failure or even heart failure. You see that the feet begins to swell. Water begins to accumulate around the leg region. And then you know that circulation is compromised. So if your feet is swelling and you are here, you need to go and run a test. Because the earlier, the better. Sometimes people take these things for granted. I have a relation who, her leg was swelling. It comes and then it goes. So she was watching it. She thought it was something else. And sometimes doctors can make mistakes that can lead to death of a patient who is supposed to live. Not as if she didn't go to the hospital. Of course, she went to the hospital and the doctor told her it was a fungal infection without running proper tests to find out what the problem was. But she was given a cream because I think she had maybe one injury that has even gone for long. But the doctor mistook that condition for fungal infection. So she was given that cream and she was applying on her leg. So the thing kept on swelling. And then she went to another hospital. And then she was diagnosed of heart disease, heart failure. But before she knew it, it was late. And then her BP was around 250 and above. And the doctors tried to, reduce the BP to no avail. A lot of injections were given, but it was late, and then she passed. So you see, when you hear of things like this, they may sound so simple. When you see them, they look so simple. It's just swelling of the leg. But there is need for you to do a proper checkup on the heart and the kidney, including the liver. Because these things can cause swelling of the legs and other parts of the body, accumulation of fluid. Many of you are going to become doctors. And that's the reason I'm bringing this up. You don't take things for granted. Even headache can kill your patients. Ordinary headache, stomach pain, vomiting. Vomiting is so common. Someone has been vomiting. And you just say it's a minor thing. But why someone is vomiting or even stooling, like the person has diarrhea, you should check it. Because that could lead to dehydration. Because as you are vomiting and stooling, you are losing water and you are also losing electrolytes. The body cells and tissue of that subject will get dehydrated, and if proper medical attention is not given to the person, you lose that person. So, I have said one of the signs and symptoms of edema is heart failure, renal failure, malnutrition, and inflammation of tissue. Inflammation of tissues can occur when you have an injury. If you notice you have an injury, a lot of reaction occurs in the body, trying to stop the bleeding, that is coagulation mechanisms. But then if you look critically around the area where that tissue has been injured, you see that there's accumulation of fluid. Okay, that is known as inflammation of tissue. So going forward, Negative water balance. Negative water balance occurs when water input is less than water output, or water output is higher than water input. Then you have negative water balance. So the implication of this is dehydration. Alright? Dehydration. The body cells are lacking water. So the cells are dehydrated, tissues are dehydrated. Such patient will require infusion. So you give the patient normal saline to normalize the water deficit in the body. Alright? There are also physiological and pathological variations. I said there are also physiological and pathological variations. Like your body water content can be low during exercise and working in hot sun. You know, when you are exercising or you are under the sun doing strenuous activity, you sweat and you lose water. Okay? You might get dehydrated. But that is not pathological, it's physiological. Because after that exercise, you take a rest, take in fluid, and the body water content can return to normal. That is physiological. There are also pathological variations, as seen in dehydration. Okay? Dehydration burns. That is when someone is burnt by fire. Okay, burns. Hemorrhage. Hemorrhage. Hemorrhage is another thing that can lead to negative water balance.
Hemorrhage.
Hemorrhage simply means excessive loss of blood. Alright? And then vomiting and diarrhea. I mentioned that earlier. These things can lead to a negative water balance. Alright? Good. Questions? No questions. That's why I like this class. People are very, very intelligent. You don't have questions. Yes? What is pathologies? I said dehydration, burns, hemorrhage, vomiting, and diarrhea. Any other question? Okay. Very intelligent people. So dehydration simply means excessive loss of body water, leading to decline in body water level, excessive loss of body water. Of course, while you lose water, you can also lose electrolytes. Excessive body water loss can occur in diarrhea, severe vomiting, sweating, fluid loss in bones, Addison's disease, diabetes mellitus, and diabetes insipidus. Also, we have renal diseases. These things can cause the body cells and tissues to be dehydrated. You'll get to know all of that as you proceed. Addison's disease, diabetes mellitus, and diabetes insipidus. Yes?
Say diabetes insipidus. I thought diabetes insipidus is as I thought diabetes insipidus is as a result of water
They
intoxication.
can't hear you.
I'm talking about diabetes insipidus. And I said that I thought diabetes insipidus is as a result of
Can you hear her from
water
behind?
intoxication.
Can you hear her?
Use the mic now. Are you scared of the mic?
But I was saying that
Put it.
I thought diabetes insipidus is as a result of water intoxication. How does it cause dehydration?
We thought that diabetes insipidus is as a result of water intoxication. So how does it cause dehydration? Hmm? The first thing you need to know is what is diabetes insipidus and what is diabetes mellitus. Alright? So we need to first differentiate the meaning of diabetes mellitus and diabetes insipidus. What is diabetes mellitus? What is the common cause of it? Yes? Who knows? Doctors. Who knows? Diabetes mellitus. A hand is up. Too much sugar. Excess sugar or glucose in the body as a result of what? Insulin deficiency. Alright, when there is excess glucose in circulation, it means there is a problem with insulin, the hormone that moves glucose from circulation and store them in the liver and muscles. Okay? So if you have diabetes mellitus, it means there is deficiency of insulin. But diabetes insipidus, what does it mean? Yes? Deficiency of ADH, deficiency of vasopressin, antidiuretic hormone. Names have meaning. Diuretic. Diuresis simply means excess what? Excess water loss via the urine. Diuresis. You are passing out a lot of water in the urine. So when you have anti, it is against diuresis. Antidiuretic hormone, which means it prevents excessive water loss from or via the urine. Antidiuretic hormone, vasopressin. So when there is a problem with secretion of antidiuretic hormone from the posterior pituitary gland, it simply means that this hormone that is supposed to help you to conserve water is not being secreted to act on the collecting duct of the nephron. And then instead of conserving water because of the absence of vasopressin, you begin to lose more water via the urine. And that can lead to dehydration. That brings us to her question. She said she thought that diabetes insipidus is to help you conserve water, right? As a result of water intoxication. Okay, that means water intoxication means you have excess water in your circulation. Hmm? Water intoxication. Well, if you have excess water in circulation, that hormone, vasopressin, will not be secreted from your posterior pituitary gland, so that your kidney will be able to eliminate that excess water, bringing the water content to normal. But that hormone is active whenever you have less body water content. So it is secreted, it goes into the blood transports the hormone to the collecting duct of the kidney, and it causes constriction of the renal blood vessels, which will now help you to conserve water to bring the low body water content to normal. So if you have excess water in your body, that hormone is inactive. So, but what I would say, diabetes insipidus will lead to the excretion of excess water in the urine. And if that is not controlled, it can lead to dehydration of the body cells and the tissues. So one of the most common cause of dehydration is diabetes insipidus. Okay? You get to know that later on in endocrinology and renal physiology. All right. Some of the signs of dehydration: low cardiac output, rapid pulse rates, signs of dehydration. You have number A, low cardiac output. Number B, rapid pulse rates, low blood pressure. Of course, if the cardiac output is low, then the blood pressure will be low. Decreased skin turgor, acidosis, sunken eyeballs, confusion and coma, and intracellular dehydration, which may lead to death. Dehydration can kill you. If urgent attention is not given to the patient. Okay. Treatment of dehydration. Treatment of dehydration. It's very simple. As a doctor, maybe a patient comes to your hospital and you observe that this patient is dehydrated. The body tissues and cells are lacking water. What do you do? Simple. Simple. What you have to do is fluid and electrolyte replacement. Alright? You just give normal saline infusion. Normal saline is different from dextrose water. With time you know that. Okay. I think that is all for body fluid physiology. Any question? Yes? Bonds. Yes. Do we have any other bonds? Which one? Hmm? What? I'm not hearing you. What? Acid. Acid bond. Okay. If they pour you acid, what happens to your skin? Huh? It will peel. And when it peels, won't you lose water? Bonds is bonds. Fire bonds. Alright? So, any other question? Someone should take the mic to him. Don't we have ushers in this class?
Can you explain it now? Explain.
Put the mic, hold it well. Addison's disease.
Addison's disease. You want me to tell you more about Addison's disease? Okay. Now, I hope you don't have any other lecture today. So that we can jump from blood to endocrinology. Do you have another lecture? You have? Oh. So let's leave that so you don't go and mix some things. You're going to do that under endocrinology. Alright? So don't be in haste. We are here to teach you everything you need to know to make you a professional doctor. Yes.
Sometimes how can insulin deficiency to dehydration?
How can
Insulin deficiency.
insulin deficiency leads to dehydration? How can insulin deficiency leads to dehydration? Okay. This is still under endocrinology, but I will just quickly respond to that so that we can go into the next topic for today. Alright? I told you that insulin, what is the function of insulin? It supplies the cell with glucose, energy, right? Good. Now, if the cell is not eating and is not drinking, remember that look, why glucose moves to the cell, water also moves with it. Okay? So now, if the cell is not taking glucose, of course, it will also lack water. And what happens to it? It's going to shrink and die. That cell becomes dehydrated. It's also lacking nutrients and water. So it's going to shrink and die. That is, if that condition is not given urgent medical attention. Okay. So this brings us to the end of